So we're going to talk about limits. Limits are sometimes confusing to people, but they don't have to be. They're actually not very tricky. Limits are really all about finding a way to describe how the outputs of a function behave as the inputs approach some particular value. And we're going to talk about this many different ways. We're going to do it graphically, we're going to talk about it algebraically, we're going to talk about it numerically. We can talk about looking at the output values as we approach from both the left and the right of our given input values. We call those one-sided limits. A limit from the left will usually have a little negative sign up by wherever we're approaching, and a limit from the right will usually have a little positive. So the words themselves are going to look something like this. I want the limit as x approaches some number c from the right of my function, or I want the limit as x approaches some number c from the left of my function. So this is from the right, and this is from the left. So let's take a look at a graph and see if we can figure out what exactly we're talking about when we talk about from the left and from the right. So here I've drawn a little picture of a graph, and it looks sort of linear, except it has this open circle at the point 2, 2. Well, that open circle represents a hole in the graph. And a hole is really not important when you're talking about a limit. A limit is asking, as I start to approach my x values, let's say I want to take the limit of this function as x approaches 2 from the left-hand side. So as I look at my x values, I notice that as I come in closer and closer to 2, closer and closer and closer and closer and closer to 2, I get really close to a y value of 2. So it appears that from the left-hand side, my limit is 2. I'm going to take a look at this same limit as x approaches 2, this time from the right-hand side. So again, I'm going to start far out in the graph to the right of 2, and as my x values get closer, closer, closer to 2, I'm going to see what happens to my y values, and I notice that they also get near 2. Now this particular function does not exist at 2. There is no function value at f of 2. There's a hole there. And that's okay, because it doesn't matter if you have a hole. You can still have a limit even with a hole. That's pretty important. You can still have a limit with a hole in the graph. I'm not really asking you what the value of that hole is. I'm just asking you what's happening as I approach the hole from the left-hand side, as I approach from the right-hand side, what's happening to my y values. So let's look at this. A function f of x has a limit as x approaches some value c if and only if the right-hand and the left-hand limits exist at c and are equal. In symbols we write the limit as x approaches c from the left and the limit as x approaches c from the right are both some value c, or some value l, sorry. And that means that the limit in both directions, without any plus or minus, is also l. So I'm going to take a look at this function over here one more time, and I'm going to take a look at what's happening to my function as x goes to 2 from the left-hand side. So as I start to come in here, I'm noticing what's happening to my function. Well, over here I notice my function is getting really, really close to the number 1. So my limit as I approach 2 from the left is 1. I'm going to approach it from the right. I'm going to look at these x values and see what's happening to my function now. Well, once again, as I get closer, closer, closer to 2 on the right-hand side, I'm still approaching that same 1. So the limit as x approaches 2 from the right-hand side is also 1. Now, that's not the same for every number here. If I look at the limit at positive 1, if I take a look and say, okay, let's suppose we want to find the limit see if I can move this up a little bit. Not really. We're going to go to the next page. Okay, so let's take a look at this picture once again. This time I want to take a look at what's happening to the limit of f of x as x approaches 1 from the left-hand side. So as I come in to the x value of 1 from the left-hand side, I see that that goes to 0. If I come into 1 from the right-hand side, oh, I see that this time it goes to 1. Well, 0 and 1 are not the same number. The fact that I'm coming in from the left-hand side and getting 0 for an answer, and coming in from the right-hand side and getting 1 for an answer, means that I don't have the same limit from left and the right. And if I don't have the same limit from the left and the right, then the limit at 1 doesn't exist. It exists just in one direction, left or right of 1, but not at 1. If I look at this example, as I approach 3 from the left, my picture is going up to 2. As I approach 3 from the right, my picture is still going to 2. Since I'm going to the same number as I approach from the left and the right, we say that the limit is 2. This one definitely has a limit at 2.